Hi everyone, welcome to Practical Python. My name is Nina Zakarenko and I'm your instructor today. This is an immersive hands-on Python course and it requires a little bit of prerequisite knowledge. So in order to really succeed today, you should be comfortable on the command line. You don't have to be a pro. And you should know a little bit about programming in some other language. So understand basic constructs like loops and variables, and those are going to be the things that set you on the path to success. If you're a little bit more of a beginner, you might enjoy the 2-day course that I did for Front-End Masters last year called Introduction to Python and Python Fundamentals. Now, you might see this course website that I have up here. You can find this at practical.learnpython.dev. Let me bring that URL up for a minute. practical.learnpython.dev. Now, I recommend that you don't just follow along on this website. Don't read because we're going to be moving pretty quickly today, and you're going to get most comfortable if you type along with me. So by typing along with me as I type, you're going to gain that muscle memory that's really going to help that knowledge stick. A little bit about me. My name is Nina Zakarenko, and let's see here. I've been coding altogether for probably about a decade now. I started out in Java. that is my secret. But I moved towards Python probably about 6 years ago now because I really liked the community and I thought that the libraries and the ecosystem were really amazing. I started speaking at Python conferences and just completely fell in love with it. Recently, I've been elected to the board of directors for the Python Software Foundation, which is really great. I get to do a lot of good work. And I've also written code for companies like Reddit and Meetup and HBO. These days, I'm a principal cloud advocate at Microsoft, focusing on Python. If you want to stay in touch with me, I'm on Twitter or LinkedIn or GitHub. All of the links are here. And then I also included links to some of the more popular conference talks that I've done over the years. You can also find my other courses on Front-End Masters. One of my personal favorites is Git in Depth, and as well as Python Fundamentals and Intermediate Python. A little bit about navigating the course. If you see any typos, which I have not made because I'm 100% perfect, but if you spot anything that you think shouldn't be there, there's an edit this page link at the top of every page, and that will take you directly to GitHub where you can open a pull request. There are navigation arrows here on the left and the right side, and you can also navigate via keyboard shortcuts, which is one of my favorite features. There are breadcrumbs on the top left here for each section, and that will pull up a table of contents right here. Some sections look like this with double arrows that have additional content, so you can just go ahead and click on that and that content will expand. If you want to copy any of the code or any of the commands, you can hit this button right here and it will copy to the clipboard. If we're working in the Python REPL, for example, where there are extra control characters that will be displayed on the course website, know that they won't be copied over. You can search in this text box up here, and as you go through the course, you'll see a little checkbox next to each chapter. You can go ahead and clear the history if you find that distracting. And again, I really suggest following along with me in the class and typing as much as possible. This is a resource for you to have because I know that when I'm done with a class, especially one that's all day, I feel like, oh, did I learn anything? I'm just going to forget everything. So it's here for you for afterwards. It's here for the exercises, or if you need to go back and figure out how to do something. but I do not recommend reading it. I want to quickly go through the course agenda. So I'm going to explain to you why Python, why you might want to reach for Python, why you might want to choose Python for your project, and talk a little bit about some of the philosophies and Python's design principles. Then we're going to move on to data types. Python is a dynamic language. What does that mean? We're going to learn how to work with numbers, strings, lists, and more. Then we're going to move on to some of the more advanced data types that Python offers, and those are sets, tuples, and dictionaries. These are container objects that let us organize other types of objects in different ways into other kinds of data structures. Then we're going to move on to functions, loops, and logic. Functions help us organize our code in a way that's more readable and reusable, and they accept arguments and defaults as needed. And loops are going to let us take action on collections of different items. Boolean logic is going to allow us to control the flow of our program. We're going to cover some practical applications of what we've learned so far, including using advanced looping types like list comprehensions, converting between different types in Python, which I believe is really one of its absolute strengths. And we're also going to cover how to work with files. Next is going to be object-oriented Python, which allows us to represent our code in a little bit of a different way. We can define reusable classes and define relationships between different objects and build modular and reusable code. We're also going to cover libraries and modules. So now that you have all the foundational understanding of how Python works, you're going to learn how to structure your code and work with different libraries, both the standard library and external third-party packages. And then in the last chapter, we're going to cover web frameworks, and we're going to talk about Django in particular. So we're going to practice all of our new Python knowledge by building a basic blog, a basic web application with some unit tests and a database. This is going to give you a great tour of everything that's available in Python. You might not be an expert in any one of these areas by the end of the day, but you will have the tools available to learn and discover more. Now, there are a few prerequisites for going through the course. You need to have a Linux, Mac, or Windows 10 machine. If you're using Windows 10, you need to make sure that you have administrative rights so that you can run your programs correctly. We're going to be working with the latest version of Python, which as of today is Python 3.9. We're going to be using Visual Studio Code and the Python extension for Visual Studio Code. Now, a lot of you are already programming, you already have your environment set up. Why VS Code? Well, I recommend that we're all on the same environment today, because if you run into any issues, this is really going to help us troubleshoot and figure out what's wrong. Once you're done with the class, feel free to go back to your editor of choice. I have a section here for how to set up VS Code with different key bindings. For example, I use VS Code with Emacs key bindings. And you can set up Vim or Sublime or whatever you're most comfortable with. Really appreciate if we were all in the same environment, and that way you can follow the steps and you know there's nothing about your machine or your editor that's going to cause any problems. I'm going to review the setup instructions for macOS because that's what I'm using, but instructions for Windows are available as well. And then I'm going to quickly show you how to configure VS Code for maximum productivity in Python. All right, so here are all the things that you should have downloaded and set up. Python 3, Visual Studio Code, and the Python extension for Visual Studio Code. If you don't have these set up right now, please go ahead and start installing these prerequisites on your machine while I continue talking. To check for Python 3.9, you'll want to pull up a terminal. So if I run Python 3 -- version, I should see Python 3.9. You should see that as well. It's especially important to install the latest version of Python because your machine, especially if you're running a Mac, might already come with a version of Python. Depending on your OS, it might be an older one, so we want to make sure that we're working with the latest and greatest. Now we want to make a project directory and create a virtual environment in it. So for this example, let me start off from the same point that you're all starting off at. Make a directory, make sure that you're in your home directory. So in this case for Mac or Linux, just cd to home and then make a directory called Pi Workshop and cd into it. Should be an empty directory. Now we want to create a virtual environment and activate it. In order to do that, we're going to use Python 3-m. The -m means run this next command as a module, which is going to be the vn, Python's 3 built-in virtual environments. And the next command is going to be a name. In this case, I'm just going to call it the standard env. It's a pretty good idea to name your virtual environments env because if you're using a standard git ignore for Python, this is one of the folders that's going to be automatically excluded, and you're not going to want these auto-generated files to end up in your Git repository. Now, if I take a look here, I should see a env directory. I'm not gonna talk about what's in this directory for the moment. We're gonna talk about that a little bit later on in the class. But basically it contains a standalone Python version, a standalone Python interpreter. And when we work in that interpreter, we are guaranteed that we are using the version of Python that we used when we created it. And any packages that we install when that virtual environment is activated are going to stay in that virtual environment and not pollute your system settings. So working in a virtual environment for a project, no matter how small it is generally a pretty good idea. In order to activate it on Mac, I'm going to source env/bin/activate, and your terminal might not be as fancy as mine. You'll probably see something that looks like this. It'll say env in parentheses followed by the rest of your prompt. And that means that the virtual environment is now activated. Now I can type Python in here. I don't need the 3 anymore. And the Python executable points to that version of Python that we used when we created the virtual environment. You also want to make sure that you have VS Code. If you are running on Mac and you recently installed VS Code, you might not have the code executable. You can check if you have it by typing code -- version. If you are on a Mac and you don't see anything here, you might have to follow an extra step. Sorry, that is right here, which is called launching from the command line, install code command on path. I'll show you how to bring up this dialog box in a second, but if you're not seeing it, the instructions are right there. Now, we want to do a little bit of configuration for VS Code. We want to make sure that we have the Python extension installed. You're not going to see anything from the Python extension until you open your very first Python file. I have a link here to some list of key map extensions if you want to remap your key bindings in VS Code to Emacs or Vim or Sublime or something else. But while we're working through the class, there's only 2 keyboard shortcuts that you're going to need to remember in VS Code. For Windows, that is Control-Shift-P, and Command-Shift-P on Mac for Show Command Palette. This is like your Swiss Army knife. It's going to bring up a window where you can type and see all of the list of different commands that VS Code offers. So if I bring that up in here, if I type Python, we'll see that all of these commands are available because I've opened a Python file and I have the Python extension activated. The other command that you need to know is Control-P on Windows or Command-P on Mac. That's going to bring up the fast file finder. So you can type in any file name for that's contained in your project, and it will quickly bring it up. If you know these two keyboard shortcuts, just write them down on a Post-it note somewhere near your desk. You're going to be using them a lot, and that's really kind of all that you need to know to get productive in Python in VS Code. Now, when you work with files, when you bring up a new Python file, if you have not done that before, if you don't have a VS Code installation, you might see some various pop-ups. So let's go ahead and create a new file. It's just File, New File, or Command-N, Control-N, and we're going to save this file as, oh, my VS Code is now angry that I have renamed my directory. We're going to call this hi.py. And if you're opening up this file for the first time, you might see some pop-ups here asking you whether you want to install a linter, in which case you do. Click yes on that. And if there are any other pop-ups for things that are missing or not installed, go ahead and click yes and install them. There's also an optional extension that you might want to install called Pylance, and it is an additional feature-rich language server for VS Code. You don't need to have it, but I find it pretty useful. So you want to go ahead and install that. Make sure that when you have this Python file opened, that the correct interpreter is opened as well. In this case, mine is the last one, so it looks like VS Code didn't automatically pick it up, maybe because of my directory weirdness. So make sure that you go ahead and select the right interpreter. Here you'll see that mine is in .n/bin/python. And now I'll see here at the bottom that I have the correct version of Python. I'm just going to bump that up a little bit. Now, what do we need to do to run Python code in VS Code? We've already gone ahead and created a new file. Let's copy this into our new file and run it. There are a few different options for running your Python files. I'll show you how to run them both from within VS Code and from the terminal. So I pasted that right in there. If you're already in VS Code, you can open up the command palette with Command-Shift-P or Control-Shift-P and select Python, run Python file in terminal. And this has the advantage of VS Code being smart, and if your virtual environment isn't activated, it will automatically select it, and you will see that it output right in the included terminal window right here at the bottom. You can also navigate to this file in your terminal and make sure that your virtual environment is activated and run Python hi.py. So this is outside of VS Code if you're more comfortable in a separate terminal or on the command line. There's one other thing that I want to talk about, and that is the Python REPL. What is a REPL? REPL stands for Read, Evaluate, Print Loop. This is an interactive Python prompt where you can type in Python programs line by line and see results right away. There are lots and lots of benefits to using a REPL. By seeing this instantaneous output, you get instantaneous feedback, which is exactly what you need when you're learning. You want to fail fast and fail often, make mistakes, experiment. There's really not much that you can break. So take full advantage of the REPL. For the first few chapters, we're going to be working exclusively in the REPL, and I ask that you type along with me. Now, the downside to the REPL is you eventually will want to store your Python code for reuse, and that's what Python files are for and Python programs. you can consider the REPL more of a scratch area. So it's where you can experiment and play and try out Python code. If you want to save the output of your REPL, you can just copy and paste that into a file, which I recommend doing if you want to go back and look at what you were working on. The REPL isn't just a tool for beginners. As a Python programmer, I use it all the time. If I can't remember what a method does or what the return value of something is, I pop up a REPL and I can quickly answer that question for myself without having to Google or read docs or whatever. So it's not just something that beginners use. It's going to be a tool that you'll have in your toolkit for the rest of your Python career. Now, you'll know that you're in a REPL when you see 3 arrow lines. Those are going to indicate that a line of input was given at the prompt. If you see 3 arrows in the example code throughout the course, don't copy them into your own REPL. The built-in copy function on this course website should take care of that for you. Now, comments can start with the # and comments will be ignored in the REPL, both if they're on a new line or if they follow a line of code. So you might see me add in some comments for some context as I type. And then lines that don't start with either of those things or a dot means that it was output produced by running input from the prompt. So let's try this out. If you want to open the REPL on your terminal without VS Code, as long as your virtual environment is activated, you can type Python and it will bring it up for you. And you should see these 3 arrows and a blinking prompt letting you know that Python is ready for input. On Mac and Linux systems, you can exit out of this by hitting Control-D. On Windows, I think it's slightly different. I don't remember the command offhand, but I'm pretty sure the REPL prints it out. Either way, on Linux or Windows systems, if you don't remember how to quit this REPL, you can just type exit as a function, and that will exit it for you if you don't want to remember the keyboard shortcuts. Now, in VS Code, we can just pull up the REPL from the command palette and have it in our integrated terminal. So to do that, Control-Shift-P for Windows, Command-Shift-P for Mac, and then Python start REPL. And that will bring up the REPL right in VS Code for me. Now we can start typing some Python code and seeing what happens. We can type a number and see that the output is just printed out. We can type we can assign a variable. So in this case, I'm going to assign the number 5 to x. You'll see here that nothing was printed out. That's because an assignment was made and nothing was returned from that assignment. So in the REPL, if you want to see the value of what's an x now, you can just type x by itself and you'll see that output again. Once we move to files and we don't have these handy features of the REPL, you're going to need to use the print function in order to see any output. We're going to talk a lot more about print later, but for the time being, you can just pass a variable to the print function, or you can pass in a string that is delineated with quotes. And in the REPL, that'll do the same thing as just typing the variable. So now you should be all set up to work on the rest of the exercises in this course. There's a bit of a checklist. If you're missing a step, I recommend that you go back in the break and make sure that you're all set up. You need to have Python 3.9 installed. You need to have the VS Code extension installed. You need to have the Python extension for VS Code installed. You need to have made a PyWorkshop directory in your home folder and navigated to it, created a virtual environment and activated that virtual environment, and open VS Code in your project directory. If you have code on your path, you can just navigate to a directory where you have a virtual environment opened and type code dot. That will open VS Code in this project directory. It should pick up the virtual environment automatically, but you'll still want to double check. If you don't have that installed on your path, that's okay. You can just launch VS Code and navigate to the project directory. It's not a prerequisite for the course, it's just a handy shortcut. And there are some steps where you can go ahead and check that you have everything. Once you're done with setup, go ahead and open the REPL either in VS Code or on the terminal, and that will set you up for the next chapter. Somebody mentioned that in Windows to exit the REPL, Control-Z works. So yes, that is the keyboard shortcut. Somebody in chat said they keep getting Python 3.8.6. That means that they might have an older version of Python installed. If that is the case and they went through the steps to install Python 3.9, they might be able to create their virtual environment or check with the version with another more specific command. So here in my project folder, I'm going to type deactivate, and that will deactivate the virtual environment that I had activated. Instead of typing this, I don't want any of you to deactivate your virtual environments. I'm just going to open a new window. And you'll see here that in my new window, I don't have a virtual environment. So if you have an older version of Python 3, you should have a Python 3.9 command. I believe in Windows it's Py 3.9. And that will let you target the more specific version of Python 3 on your system.
There was one other suggestion of potentially using REPL if all else fails. Is that a good option or not? Like the online Python runner?
No, because if you want to run Python programs on your system, you want to make sure that you're all set up. For the person in chat who's on Python 3.8, that's okay. It's a modern enough version of Python 3 that they shouldn't be too far behind. And I'm not going to cover any Python 3.9 specific features in class today, but they do want to get their environments dialed in. Unfortunately, I'll chat about this in a little bit. Versioning in Python is something that has, there's some history there. And it's not the easiest thing to do. I imagine that that's where the history of virtual environments came from originally, is to solve some of these problems. So it is possible to have multiple versions of Python on your machine, and you want to make sure that you're using the right one for your project. All right, so what is the draw of using Python? How is it different from other languages? What advantages does it offer? Python is a dynamic programming language, and this really caught me by surprise at first. It was created by Guido van Rossum in the late 1980s. That means that Python is 30 years old. That means that it's older than some of you. It is old enough to vote. So a lot of folks think that Python is a new language or that it's new on the scene. That is not true. It's just been gaining a lot of popularity in probably the past 10 years or so. There's also this common misconception that Python is only a scripting language. It's really simple, and that is not true at all. Django, a web framework that's built in Python, is used to run Instagram, which is one of the largest websites in the world with the most users. It powers parts of Reddit, it's used at Netflix, and early versions of Dropbox were built almost entirely in Python. Dropbox credits a lot of its success to Python because Python is easy to read and easy to write, and it's easy for teams to collaborate in Python. They had this idea and they were able to get a product out the door as quickly as possible. And then when they had to scale, that was something that they started dealing with by replacing parts of their application with Go or other more performant languages. But they didn't optimize when they didn't need to, and that let them have this very, very successful company. It's also becoming an increasingly popular language for education of all ages. There are Python books for kids. Python is taught in universities. And I found this great quote that in 2014, Python was the most popular teaching language at top US universities. And if you know Python, you might not have a hard time finding a job because it's one of the fastest growing programming languages. Guido said that Python is now also the language of amateurs, and I mean that in the best way possible. That means that the language is accessible to a lot of people. One of the great things of Python is that it's open source. It's an active development. There's a committed team of core contributors, and there are also a lot of issues that are tagged welcoming for beginners. So as you advance in your Python journey, if you decide that you want to contribute back to the language, that is something that you can easily do. We chatted a little bit about versions in Python. You might hear something about Python 2 versus Python 3. What's that all about? I will say that this is maybe a little bit of a stain on Python's history. Python 3 was actually released in 2008, and its adoption was very slow. There were a lot of really popular frameworks that didn't want to migrate because it would have been a lot of work. And because of that, a lot of folks stuck to Python 2 instead of Python 3. There were some breaking changes that were introduced. At this point, that chapter is now fully closed. Python 2.7, which was the last version of Python 2, is deprecated. It has reached its end of life. It's not getting critical security updates. It's not getting critical new features that you might want to use. So it's time to use Python 3 and move on from Python 2. All of those popular libraries and frameworks have now migrated as well and are likely not supporting their Python 2 features because that's double the work. So this course is going to focus on Python 3 only, and I would encourage you all to use Python 3 for your personal projects and projects at work. Python has an incredibly rich, fully featured standard library. There's a saying that Python is batteries included. So anything that you might want to do, like working with JSON, all of those are included in the standard library. You don't need to install any additional packages, and there's a link here into the standard library, and you can kind of go through here and see what is available. There's a lot of stuff. There's also the PyPI package index for third-party packages. As of today, there are almost 300,000 projects and almost 500,000 users. So this is where you go where you want to find something that's maybe more modern or more niche. And there are lots of third-party packages available for many different uses. There's tons of stuff for AI and ML, SciPy, NumPy, Pandas, PyTorch. There are great options for hardware and microcontrollers. There are two very popular web development frameworks that are Django and Flask. Lots of tooling for DevOps. And the absolute best part of Python is actually the incredible community. So after this course, I encourage you all to continue in that community. PyCon US is the biggest yearly conference with approximately 4,000 attendees. There are lots of local user groups. A lot of them are listed in a wiki that is linked. A lot of these groups are now having online and remote events that you can participate in. And there are also many great and supportive groups for women and non-binary developers, such as PyLadies and Django Girls. And these organizations tend to have chapters in most major cities, and they do a lot of really, really great work. So a little bit about the philosophy of Python. A lot of ideas in Python were formed by something called the Zen of Python. It's a collection of 19 software principles that was sent to the Python mailing list in 1999. And you can actually find the Zen of Python included in the Python distribution as an Easter egg. So let's go to our REPL, wherever you had that open, and type import this. And we're not going to read this whole thing, but the top few tenets: beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, flat is better than nested, sparse is better than dense, and most importantly, readability counts. So as you advance through your Python career, you'll see more and more of this in practice. Python code should be simple. You shouldn't try to make the most, the smallest one-liner that nobody else can understand. Python can give you those tools. You can do it, but you shouldn't. You should focus on making your code very clear, very simple, very readable. Flat is better than nested means don't have arrow-shaped code. So no if statement, if statement, if statement, if statement. Not a ton of nested loops. Try to keep everything as close to the left margin as possible, and really focus on this. This is what makes Python different from a lot of other programming languages. Now, a way that Python encourages you to write simple, readable code is with a style guideline that's included in the language's list of official proposals. It's called PEP 8. And if we take a look at this, PEP 8 gives coding conventions for Python. Everything from indentation to maximum line length to where blank lines should be, to how the spacing around equal signs works. You don't have to remember all of these rules because tools called linters, you should have installed a linter in VS Code, will show you warnings when your code doesn't meet PEP 8 standards. Know that the warnings that linters give, they're not syntax errors. Your code will still run, but it won't meet accepted Python code style standards. Not very important when you're working on your own, but much more important when you're working on a team and collaborating with others. There are a few other Easter eggs that I'm going to show you. Actually, I don't know if this one works in Python 3. This was a Python 2 Easter egg. There we go. So if you type from __ future import braces, like will Python, the programming language, ever get braces? You'll see a syntax error and the message is not a chance. So Python won't be looking like JavaScript anytime in the near future. And then one of my favorite Easter eggs is if you import anti-gravity. This will take you to an XKCD comic about Python that says, "You're flying, how?" with Python. I learned it last night. Everything is so simple. Hello world is just print hello world. This is Python 2 and Python 3. You need those parentheses. So yeah, Python's a pretty fun language, but it's also very, very powerful. We're going to take a short break before we talk about the anatomy of a Python program and jump into data types. Now that you know all about Python, you know how to set up your environment, I'm going to quickly show you the anatomy